Hello and welcome to 2015 question C2. It's our structural forms question. The graphic on the right shows a packet of potato crisps, so our Pringles packet. These potato crisps have a very distinctive surface shape which is based on a hyperbolic paraboloid. Okay, so you might have known it before, but our Pringles are all hyperbolic paraboloids. The projections of one of the crisps are shown in C2 below, so we have our plan and elevation here of our crisps. The perimeter is an ellipse in plan, so A, B, C, D, the perimeter there is an ellipse. The surface of the crisp is formed by extending the hyperbolic paraboloid surface A, B, C, D. So when we have our surface here, we extend on, we'll find points there on our elliptical shape, plan and elevation. Draw the given plan using the same number of elements in each direction on the surface of the crisp as shown. So we want to draw our ABCD in plan and then find these straight line elements. So let's start off there. Keep this close by so you can see it. Draw our axis here. We're going to have, I suppose one more thing. We've got scale 2:1 and a large scale, so all of these measurements, 75 and 20, we can double them. So that's 150 and that's 50. Okay. So 75 to the left. 50. Okay, so that's my A, C. I need to find D then. D and B are at an angle of 35. So let's find D. That's D. We can measure 35 again, but just to make sure this is all symmetrical, I'm actually just going to transfer that distance because it's equal on both sides. Right, so that's B. So here is surface A, B, C, D. Alright, so same number of elements in each direction, so we've got 1, 2, 3, 4, 5 spaces. We're going to divide up this into 5 equal parts. So a line at any angle, I'm actually going to do it down here, out of the way. And step off 5 times. One, 2, 3, 4, 5. Join our last point up, and it's sliding set squares from here. Okay, so that's divided that up, and now we're going to have parallel elements to CD, sorry, to AD and BC, so parallel elements, and I'm going to draw them a little bit longer than they need to be. So Okay, now I could divide up another line into equal parts, but just to do a little bit quicker, I can actually locate points just by finding them there directly above. So as I said, everything here is symmetrical. Okay, now I can use my sliding set squares again. Extend them a little bit longer than I need to be. I need to move this. Okay, so those are my straight line elements, and draw a given plan. So the last thing we need to do now is find our ellipse. So concentric circles method. So that's what it's setting up in this question. Minor axis, a minor circle, my major circle, 60 degrees, so a lot of this could be confusing now. Okay, so let's find the points on our ellipse. Okay, and drawing a freehand curve, always looking at the point we're travelling to, not at the point of our pencil. Just give us a nice gradual curve. Okay, so that is our plan completed. Alright, now they want us to draw the given elevation from the plan. So we're going to locate A, B, C, D first of all, and then our straight line elements. So X, Y line. A is on the ground, B and D vertically up, and they're up a height of 50. And C is on the ground where the X, Y is up. So A, C, B, comma, D, and that's our X, Y line. X, Y. Okay, let's join those up. Okay, now we're locate our elements on those. So I've divided those up in my plan. So I'm just going to locate points here. Elevation. Okay, so join my points up, and I'm also going to make them longer than they need to be. So same as what I did below, longer than it needs to be. Longer than it needs to be on all of these. Okay, so now we want to follow our points along. Okay, so if we imagine this straight line element, okay, this corresponding element is in this position. Okay, so I've got points that I want to, where it's extended, that I want to carry on up. It's actually, so I will call that this straight line element. Is that point that I want to carry up corresponds to this. So extend that up, that finds a point here, and let's go along to the next one. And to the next one. So where the ellipse intersects these straight line elements, we're giving us points on the external part, and move on to the opposite side. Okay, so that's in the top half. Now I also need to find the bottom half, which is actually drawn first. Okay, so we just draw this. The more elements we have, the more of a curvature that has, but we're happy with that curvature. So freehand. So that is part B now completed. So they want us in part C to show the curvature of the surface when intersected by a vertical cutting plane passing through points B and D. So essentially if we sliced down vertically through BD, what's the curvature that's going to be found? So we can do that by projecting an end view, or I can just create an auxiliary view. I think I'm going to just create an auxiliary view in this. So I'm just going to use a cutter here to highlight where the cut is happening. So from B to D, here's the corresponding cut. Okay, now project out this direction. So anywhere out here, x1, y1. Okay, so project out 3 points that I have. So I've got, okay, I'll draw that heavy X1, Y1. So B and D, height of B and D, I need to transfer from my elevation. It's an auxiliary elevation I'm creating, so heights come from my elevation. So the height of D, height of B. Okay, the nose height then, which I projected from the center there. That's going to be where it turns. That's another point. And other points then that I can find. Looking at it here, it's kind of tough to see, it's a little bit unclear, but let's just look on our graphic here. We've got this point, this point, this point, this point. Okay, so I've done that, done that, I've done that. Now we want to find these points. Okay, so if I look at, I'll actually project now first. Okay. So if I look at this straight line element and stand up, this is the corresponding straight line element. So that height is what I'm looking for there. So I know everything I've done is symmetrical there, but I'm going to just take that height. Okay, so that straight line element here is, okay, and here is the height it is cut at. Okay, and actually corresponds to the same straight line element on this side, so I can take that same height, and now our last bit of height is that straight line element followed up. So this one followed up there, go across, so it's just right there. So tiny bit above the height that I had been using for the center, just there and there, because it's symmetrical the whole thing. And now I have my profile. Okay, so I might even highlight that with my orange just to show that it's the same profile cut. Okay, so that's my part C, now finished. Finally then, draw the plan and elevation of the shortest distance between skew lines A, B and CD. Okay, so because things are getting a little bit muddled here, I'm actually going to highlight these skew lines. So AB and CD. Just use the same color. A, B, and C, D. So what I want to do is I want to take an auxiliary looking perpendicular to these skew lines, and we'll see where they cross, where they create an X. So out here, here's my XY line, X1, Y1, sorry. X1, Y1. project out A, D, B, and C. Okay, so height of A, it's on the ground, height of C, it's on the ground, B and D are that height taken from my elevation, because it's an auxiliary elevation. Here's D, here's B. So A, C, D, B. Let's draw them in as skew lines. Just draw them in dark first and then put the blue over it. Okay. And BA. Okay, so there are my skew lines. I don't think the blue is really coming out on camera, but let's zoom in just a smidge just so you can see this a little clearer. Okay, now here in this point, right there, that is a point view of the shortest distance. So, point view of shortest distance. So we are going to project that back onto our plan view. Moving. So project it back onto my plan view. So I'm right through the middle, interesting enough. Right, and that is the shortest perpendicular distance, or shortest distance between skew lines. And read the question. Draw the plan and elevation of the shortest distance between skew lines. They're not asking me to measure it, so but I do need to project it up to the elevation. So project that up onto AB. AB, project that up onto CD, project it onto CD, there, there, that is the shortest distance. Okay, I just show arrows to where they projected. Okay, so that is part D completed. Okay, so not a very difficult question, but a little bit complicated maybe in all the construction lines and everything that goes on in the plan view. Okay, but that's question C2 2015.